Welcome back. So part B, 11.5. I want to state something really quickly. So at the very end of that last video, recall that this was the equation that you got for that plane. What if you were taking a test and you at this point right here you started to second guess yourself, right? How could you assure yourself that that you're in the right? Well, here's what you could do. You could plug in your points, right, and see if the equation is true. So you could plug in 2, 1, 1 and see if you get 0. And same with the other points. That's just a built-in check. Now, what I want to do for this second part of this video, I'm not going to spend a lot of time on the why, the theory. I just have to choose my battles with, so we're going to jump into the how. But if you want the angle that's formed between two planes, right? So let's make sure you understand. So we have two planes, and if you want the angle that's formed between two planes, the way that we do that is we need two vectors. The first vector is normal to the first plane, and the second vector is normal to the second plane, right? So you can see n sub 1 is normal to the first plane, perpendicular, right? And n sub 2 is normal to that second plane. And then at that point, it's not that bad. You have two vectors, and we've already practiced finding the angle between the two vectors, right? That was back in the first couple sections. So this is the formula that we're going to use. All right, really, before I go any farther, if two planes, if you do have those normal vectors n1, n2, you get to make a statement that the two planes are perpendicular if the dot product is 0, and you get to make a statement that the planes are parallel to each other if the vectors are scalar multiples. Okay, so example 4. It says find the angle between the two planes. Well, okay, so we have our two planes, and we're going to proceed to find the angle between the two planes. By the way, we need we're going to start off with finding those normal vectors, but a little bit harder of a question, maybe you'll agree, is the second part where we say then find parametric equations of the line of intersection. So notice that you have two planes here, and where they intersect at a line. That makes sense. If two lines intersect, they intersect at a point. So if two planes intersect, they're going to intersect at a line. So we want the angle, and we want that equation of that line. Let's start with the angle. Okay. So if you listen to me right now, I'm going to save you a lot of time. Okay? I'm going to give like a shortcut, if you will. I'm going to go back. If you're given your plane in general form, right? If you're given your plane in general form, it is very easy to spot the normal vectors. Right? So watch how easy this is. So let's start with the first plane. So since it's already in general form, I can look how quickly I can go right to the normal vectors. I just take the the coefficient of each of those variables. All right, that just saves me a lot of time of, plotting, taking cross products and so forth. I was instantly able to go to that those normal vectors. Now that I'm here, let's just go ahead and use that formula that's on the previous page. So in that formula is if you want cosine of that theta, that angle between those two planes, is, well, we're going to take the dot product of those two normal vectors, and we're going to divide that dot product by the magnitude of each. All right, the product of their magnitudes. All right, so I'm going to go ahead and do this quickly. So the magnitude of n sub 1 is the square root of 6. The magnitude of n sub 2, the square root of 17. And the dot product, I'm just going to write this here. So n sub 1 dot n sub 2. We want the absolute value of that. So that's the absolute value of -6, which is just equal to 6. All right, so I know what to plug in this equation. Ready? Let me go ahead and do that now and finish this up. So that means cosine of theta is equal to, so it's the absolute value, so 6 over the square root of 6 times the square root of 17. All right. You don't know how many students, even at your level of mathematics, write this, and they think that that's an angle. That's not an angle. That is the cosine of an angle. If you want to know the actual angle, then you need to use cosine inverse. And that's roughly, in degrees, I think that's 53.55 degrees, or 0.93 radians. All right. So I went through that quickly. If you ever catch any silly mistakes, feel free to shoot me an email. Okay, so we found the angle between the planes, but we now need the line of intersection, if there is one, right? I mean, it's possible that the planes are parallel to each other and they never intersect. But how do we find the point of intersection? I say point of intersection, but it's actually going to be a line of intersection. Okay, so I just like, and I'm not going to dwell on this very long, but just like in 2D, you would use a system of equations to find the point of intersection. We're going to do the same thing, except we're going to use a system of equations to find the line of intersection. So okay, let's proceed. By the way, if you know how to, if you know how to use matrices, that can, no, let me not do that. So let's go ahead and I'm gonna multiply this top equation by -2. All right, so let's multiply this top equation by -2. That will give me a -2x here and a positive 2x here, which will aid when I cancel out. So let's see what that looks like. So that would now be -2x plus 4y minus 2z equals 0. 2x plus 3y minus 2z equals 0. And if I were to add, I end up with 7y minus 4z equals 0. Now, I'm going to use a shortcut here since we're trying to get to a parametric description. I'm going to go ahead and solve this equation for y. So y is equal to 4z over 7. All right, and hopefully this shortcut doesn't, hopefully this shortcut works out okay for you. So what I'm gonna do is I'm gonna plug 4z over 7. I need to pick an equation. I can pick, either one of those equations, but I need to plug that in for y. I'm just gonna pick the first equation. So that's what's gonna happen. So let me go ahead and write that out. So now I have x minus 2 times, and I'm going to be plugging this in for y. So 4z over 7. Okay, plus z equals 0. All right, so let's distribute all that out. Let's see what that looks like. So now we have x minus 8/8 z plus z equals 0. I want to combine these z's. So that gives me x minus 1/7 z equals 0. And now I want to solve for x. X is equal to z over 7. Okay. So let's free up some space here. So remember, your parametric description is, we would have x equals y equals z equals. All right. So how do I proceed here? So what I have, let me go ahead and write what I have so far. As it sits, I have x is equal to z over, 1/7, z over 7, So x is equal to z over 7. And I have y is equal to 4z over 7. So far, this is what I have. Now, normally what we do at this point is we introduce a parameter, t. And here's the beautiful thing: I can choose. I can let this arbitrary parameter t be anything I want it to be. But watch what I'm going to do, because I'm awesome. Ready? Watch. Let's just let t equal z over 7. You're like, why'd you do that? Because watch how easy this becomes. Now, everywhere I see a z over 7, I'll just put a t there. Well, here's a z over 7, so I'll just put a t here. And now this is 4z over 7. Right, so and then of course I need to also figure out what z is. So in terms of t, ready? So x is equal to z over 7, which I'm going to call t. So what would y be equal to then? Well, y is equal to 4 times z over 7. So that's 4t. And the last thing I need to have z. How do I do that? Well, go back to your equation, plug in t for x, plug in 4t for y, and then solve for z. I'm getting z is equal to 7t. All right. I have a feeling you didn't like that. That's okay. That's all right. You'll have to forgive me. Um, are you ready? Are you ready to show you how? Listen, if you're like, I hated that. I hated the way he did that. I just didn't get it. Well, watch this. Ready? If you would have taken, you could take the cross product of these two right here, and that would have got you this as well. I'll say that one more time because that's my trick. I don't like to give away my tricks. If you just take the cross product, n sub 1 cross n sub 2, if you just take that cross product, you would have also got to here. So, why didn't I do that? I don't know. I wasn't in the mood to do it. All right, so I'm gonna skip this one. This is a very good question. What I'll do is I'll give you the answer. It's the angle. The answer in this case is roughly 89.1 degrees. If you can produce that, please let me know. All right. I want to give you some props. So let me go ahead and go to the last two concepts. And what I want to, how do I say this? So these are just two formulas that you're just going to have to have access to, right? So if you want to find the distance between a point and a plane, well, here's your formula. I'm going to skip ahead and then come back. So here's the formula for a distance between a point and a plane. Here's the formula for the distance between a point and a line. So this is the way you would think about the distance formula. If you want, and this is the way we would do the distance from point to line, point to plane. And the main difference here is one makes use of a dot product, one makes use of cross product. So these are a couple concepts that you're going to need to practice. I'm just going to do one of them for you. I've already practiced cross products and dot products with you, but I'm going to just do one more, and I'll make a couple more closing remarks and we'll be done with this section. So for example 5, we're asked to find the distance between this point and this plane. All right. So this picture does it's elusive, right? Because you won't be given a picture like this on a test. But so we have the point, we have the plane, and the picture tells us exactly what we want, the distance between them. All right, how do we proceed? Well, first thing I'm gonna do is write that equation that's on the previous page, and that is the absolute value, and it's just the dot product p to q with the normal vector, so over the magnitude of the normal vector. All right, let's see if you were listening to me not too long ago. Ready? The normal vector. How do you find a vector that's normal to this plane? Well, I hope you're listening, because if you have it in general form, which you could bring the 6 over here, it would be equal to 0. Don't you recall that the normal vector, the A, B, C, can be grabbed quickly from just those coefficients? So that's a quick way of getting right to the normal vector. We can just grab it. So that's going to be 3, -1, 2. There we go. We got our normal vector. Now let's take a quick look at the formula for the distance. All right, well, it appears that we're going to need, at some point, the magnitude of that vector, so we may as well do that right now. So the magnitude of that normal vector is going to be, let's see here, that's going to be the square root of, I'm going to go ahead and square this out. I just don't want to do it too quickly. I don't want to mess up. So we got 3 squared is 9, and negative 1 squared is 1, and 2 squared is 4. So that's the square root of 14. All right, so we got this part. All right, so what is it that we don't have? Well, we have the normal vector n. We have the magnitude of that normal vector n. What we don't have at this point is a vector p to q. We have a q. We just don't have a p. So they say q. Oh, we're told that q is 1, 5, negative 4. All right. So how do we produce some point P? All right. The way that you, so let's see if you agree with this first, because we're almost done. So stick with me. That every point, do you agree with me? So look, so this plane right here, every single point in this plane can be found from this equation. Agreed? Well, if you want another point, then, and it doesn't matter what it is, then watch how simple this is. Let's just take our plane. So our plane is 3x minus y plus 2z equals 6. Watch. Let's just let, I don't know, let's let y equal 0. Let's let z equal 0. And then solve for x. That will be a point on that plane. So let's see what that looks like. So that would be 3x, right, minus 0 plus 0 equals 6. In other words, x equals 2. So guess what? The point 2, 0, 0 is another point in that plane. And now let's form the vector. We're going to go from, let's see here, so we'll go from P to Q. All right, so 1 minus 2 is negative 1, 5 minus 0 is 5, and negative 4 minus 0 is negative 4. All right. Guess what? You got it all. You got your vector P to Q, you got your vector n, you got your magnitude of vector n. The only thing left to do is to plug, you got to take the dot product of these, but you just plug everything in. So I'm going to give myself a little bit of space here. All right. And let's finish it up. So that distance is going to be the absolute value of the dot product. So negative 1, 5, negative 4, dot n, which is 3, negative 1, 2. So, and then we want to divide that by the square root of 14. All right, that just equals, when you do your dot product, you'll get 16. So you'll get 16 over the square root of 14. All right, so what's the distance between that point and that plane? There it is. Don't turn, I know that's roughly 4.28. All right, but this is not This is not engineering class. It's not physics class. We don't want roughly. The distance is roughly. We want the exact distance. So leave it as 16 over the square root of 14. Nothing else to do. Okay, so the only thing that I want to tell you is I'm not going to do it now, but there's some problems, practice homework problems from the textbook on the distance between planes. Right? So you'll have to just search through the textbook, and it'll be the distance from one plane to another plane. You should go through some of those problems, right? Again, if you're using the Larson book, you can go to CalcChat and look at the step-by-step solutions, but you want to be ready for questions like that. Other than that, I'm not going to do a distance from a point to a line, because it's very similar to the problem we just did, only that we're using a cross product instead of a dot product. So we'll go ahead and conclude, and this is the conclusion of 11.5.